Today I want us to, when I go through a slide, so after the first slide, I'll pause and then you'll ask questions or comment, like in the slide. Okay. Hi, Nundu.
Hello.
Okay, so I'll just start with the presentation. Okay, so after, I think the second slide. Can you guys see on the presentation?
Yes.
Okay. So now in descriptive geometry, we are working with points and lines in space. So how can I explain points and lines in space? We can say that points and lines in space are just points and lines that are not attached to anything. They are just in space. So first thing that I want us to look at is the different planes that we are dealing with. So we have a vertical plane, a horizontal plane, and a side vertical plane. The vertical planes in the pictorial view there are in gray, and then the horizontal plane is in white. So now the confusion starts from when you try transitioning from the pictorial drawing to the orthographic drawing. So on your left hand side, you can see there is an orthographic drawing like there. So it has also a vertical plane, right vertical plane, and horizontal plane. But from the pictorial drawing, what happened with the horizontal plane and the side vertical plane is that the horizontal plane unfolds to align straight with the vertical plane. If you can look at the orthographic drawing there.
Hello.
Sorry? Hello? Are you saying something? So the side vertical plane also unfolds to align with the vertical plane on the side. Okay. And then describing the position of a point or the position of points, the exact position of points, we're going to use the coordinates of a point. So looking at the pictorial drawing on your right, point E with the uppercase letter there. Point E is a point in space. So it's between the vertical plane, the side vertical plane, and the horizontal plane. Those lines that you see there are below, there's a line below uppercase letter E and a line from the uppercase E to the side vertical plane and to the vertical plane. Those lines are just construction lines. So they indicate the distances from the uppercase E to the planes. It's either to the vertical plane, to the side vertical plane, or to the horizontal plane. So the three ways that we use to describe the exact position of a point are as you can, the coordinates of a point, the height of the point above the horizontal plane, or the height of the point above the horizontal plane. So if you can see, you look at the pictorial drawing there, the uppercase E, there's a line below the uppercase E to the horizontal plane. So that distance is the height of that point above the horizontal plane. The line below the uppercase E represents the height above the horizontal plane, the height of point E above the horizontal plane. The second point is the distance of the point in front of the vertical plane. So from the uppercase E to the vertical plane, that construction line there represents the distance of point E in front of the vertical plane, and also to the side vertical plane. It is the distance the point is in front of the side vertical plane. So these coordinates are the ones that you are going to use when you are looking for the exact position of a point. Looking from, I think, the assessment 2025, or they'll want you to figure out the coordinates of the triangular lamina there. So you are going to use this method. These methods are the three ways of describing the exact position of a point. Any questions? Guys, we can pause for questions and comments. Hello? Questions, guys? Any question? Nondu?
It's not. I'm not sure if it's applicable or what, but I want to ask. You see, point E.
Yes.
Where would it be on the orthographic projection?
It depends from which view you are looking at the drawing. So from the, if you are looking, it depends on, if you are looking from the front view, then it will be on the vertical plane. Point E will be at on a vertical plane. If you can look at the orthographic drawing on your left, you can see point E there on the vertical plane. Can you see point E on the vertical plane?
Where?
On the
orthographic projection.
orthographic drawing. Look at the vertical plane. There's point E there.
Yeah. Okay, I can
That
see.
E is viewed when you're looking at the drawing from the front view. Ne? And when you're looking from the top view, you're going to see point E on the horizontal plane.
Plane.
You
Okay.
see,
Okay. Yeah, I
and you see
understand.
in the horizontal plane in the orthographic drawing.
Mm.
And also from the left hand side, or from the
Yes.
side, you're going to see point E in the side vertical plane there.
Yeah. Okay, I understand.
Yes.
Thank you.
Another question?
There's questions on the chat, but I'm not sure if you can see it.
When you say point E, do you say the capital point E?
Yes, the upper case E, capital letter E. Are we good?
Yes.
Okay. So we can move on now. Or Nondu, are you saying there are questions in the chat?
Yes, yes. They were asking. Oh, let's see.
It's just
Shanice was still confused, but I think you've answered her.
okay.
Yeah.
So moving to the next slide. Plot a single point line in a triangular lamina. So as I was saying in the previous slide that that to plot a point or a single point, a line or a triangular lamina, you'll have to use the coordinates of that point. So most of the time they give you the coordinates of a point or the points. So looking at the coordinates of the triangular lamina, it has 3 points, which is A, B, C. It's a triangle, so it has 3 points. So it means every point there has 3 coordinates. Looking at point A, they say A lies 75 millimeters above HP, 60 millimeters in front of VP, 55 millimeters in front of side vertical plane. So each point must have 3 coordinates. Another thing is that I wanted to explain was the difference between the vertical plane or the coordinates of the vertical plane and the coordinates of the horizontal plane. So I want us to look at the orthographic drawing on your bottom left. Bottom left, the orthographic drawing there. So the XY, looking at the XY, from the XY in the front view. So we're using first angle orthographic projection. So you know that front view is at the top, top view is at the bottom. So looking at the front view, from the XY in the front view to point B, there in the front view, that is the height of point B above the horizontal plane. So when you are looking at the front view, from the XY up, those are the heights of those points above the horizontal plane. But when you move from the XY down to the top view, for example, from the horizontal plane to point B in the top view, that is the distance of point B in front of the vertical plane. You need to understand the difference. So from the XY down in the top view, the distance from the XY to point B is the distance in front of the vertical plane. But remember, this plane that we are at in the top view represents the horizontal plane. But these distances, point B, point C, and point A, are at the distances in front of the vertical plane. So from the XY, when you measure from the XY down in the top view, you are going to use the coordinates of the vertical plane. Like when they say point B is 30 millimeter in front of the vertical plane, you are going to measure in the top view. So if they say point B lies 30 millimeter in front of the vertical plane, you are going to measure from the XY 30 millimeter down. But when they say point B lies 30 millimeters 30 millimeters above the horizontal plane, then you're going to measure from the XY up in the front view. When they say point B lies 30 millimeters above the horizontal plane, you're going up in the front view. When they say in front of the vertical plane, it means from the XY down to the top view. Any questions on that? Any questions? Questions, guys? Are you fine? Do you understand the measurements or the distances? Hello? Can I get a response, guys?
You can go on to me.
You can go on. I do understand the below and the above and in front.
Okay. Okay. And another thing is when you're working on the side vertical plane, it's still the same. So point C, they'll say point C lies 45 millimeters in front of the side vertical plane. So this XY represents the side vertical plane. You can measure from this XY to C there, which means that point C in the pictorial view. Can you see point C in the pictorial view? So point C lies 45 millimeters in front of the side vertical plane. So this is the side vertical plane. So point C lies, it means the distance between point C and the side vertical plane is 45. So it means from the XY in the orthographic drawing to point C, that distance there is 45. Okay, if there are no questions, I'll move to the next slide. Now, dealing with the different lines and the different rules. In the descriptive geometry, we have the perpendicular lines, inclined lines, and oblique lines. Starting with the perpendicular line. So when you have a line in space, so a line has 2 points. At still points, but 2 points makes a line. So when you have a line in space, like in the pictorial drawing there, looking from the front view, where I wrote front view there, looking from that side, looking from that view, you are going to see a line in the front view or in the vertical plane, an AB line, a straight line. But when you're looking from the top view, you're going to see point A, which will be represented by a dot. You only see a dot when you're looking from the top. So imagine if it's you standing on the ground and someone is looking you from the sky or from the top. So you will only see your head and shoulders because you are looking from the top. But looking from the front, you'll see a line. So the rule says if there is a point in one view, the line in the opposite view is the true length. So if there's a point, in this case, there is a point in the top view. There is a point AB there. So it means the line in the opposite view, which is the front view, that line is the true length. Again, what I explained in the previous slide was in the orthographic drawing there, from the XY to point A, from the XY to point A, that is the height above the horizontal plane. If they give you the coordinates, they say point A lies 50 millimeters above the horizontal plane. You will measure that distance in the front view. So you'll measure from the XY up 50 millimeters. That's point A. And then moving to the inclined line. So the inclined line or parallel line means the line segment AB in the pictorial view. The line segment point AB is parallel to the vertical plane. It can be parallel to either of the planes. It can be parallel only to the vertical plane or to the horizontal plane. But in this case, that line, it's parallel to the vertical plane. So if I shine a light from the front view to the line segment AB, we'll have a reflection on the vertical plane there. And that reflection line will be equal to the line segment AB, which will represent the true length of line AB. It means that line AB is parallel to the vertical plane. But looking from the top view, that line, the shadow of that line in the horizontal plane will not be the true length of that line. Looking from the top to line AB, line segment AB, the shadow in the horizontal plane will not be the true length, because that line, when you're looking from the top view, is at an incline. You will not see that is at an incline, but looking from the front view, you can see that that line is at an incline. So it means it's not represented as the true length in the horizontal plane there. So the rule about this says when a line lies parallel to the XY origin, the line in the opposite view will always be the true length. So looking at the orthographic drawing there, in the top view, AB is parallel to the XY. Line AB in the top view lies parallel to the XY. But in the front view, it's not parallel to the XY. So the rule says when a line lies parallel to the XY, as in the top view there, AB, you can see that it is parallel to the XY. So it means line AB in the front view will always be the true length. Since line AB in the top view is parallel to the XY, it means line AB in the front view will always be the true length. Any questions?
Nope, I'm good.
Okay. Nondu.
I'm also good, thank you. I understand.
Okay. Okay, in that case, we'll move to the next slide. So here's an activity from your assessments, activity 16. So looking at this drawing, looking at the front view, first we can read the information, because it's important in the descriptive geometry to read the instructions of what exactly they want. So in this case, first point, they said draw, no, they want the total length of the wire. So you have to look at the dimensions and the wire, if it has the true length or not. So looking at A, B, C, D, you can see, okay, it's a wire in space. It's not attached to anything. It's just a wire in space between the vertical plane, the horizontal plane, and the side vertical plane. But in this case, we're dealing with the vertical plane and the horizontal plane. So now, looking at AB, AB looks like it is perpendicular to the XY. It looks perpendicular to the XY from the front view. So to be sure that it is perpendicular to the XY, you have to look in the top view. And if you see a dot in the top view, then it means line AB in the front view is the true length. So in this case, you can see on the top view, there's AB there. There's A prime, B prime. So it means there's a dot there. It means there's a dot in the top view or a point in the top view. Then the rule says if there is a dot or a point in one view, then the line in the opposite view is the true length. So it means 51 is the true length of AB. It means 51 is the true length of line AB there. And then moving from point AB to BC. BC in the front view lies parallel to the XY. You go and look in the top view. BC is also parallel to the XY. So it means 32 is the true length of line BC, because that line is parallel to the XY in the front view and also in the...
Can I please ask,
Yeah.
if both lines are parallel to the XY, so that means those lines are the true length?
Yes, it means that line is the true length.
Okay.
Yeah, so it means 32 is the true length of BC. So you can add 51 plus 32 because you have AB and BC. Now you are short with CD. Now CD is not parallel to the origin from the front view, and also is not parallel to the origin from the top view. So it means line CD is an oblique line. Line CD is an oblique line. So it means you have to find the true length of line CD using one of the methods. It's either you use the cone method or the rebutment method. Any questions before we move on to the oblique line?
Can I please?
Okay,
Okay.
ask first.
Must I ask?
Yeah.
Okay, I wanted to ask that from AB to BC and CD, you're
Yes.
gonna add that together to get the true length of the wire. You won't do it separately like AB. The true length of AB is 51, the true length of BC is 32, and then we're still gonna look for the true length of CD. So after you've got that, are you gonna have to add that and say the true length of this wire is so and so?
So after finding the true length of line CD, you go down and write 50 AB, right?
Mm,
Is 51, and then plus BC 32 plus uh the true length that you would have got for CD. Then
okay.
you combine those measurements, and then you get the total length of the wire.
Okay.
Yes.
Okay, thank you.
Okay, I'm still confused with line AB because when I look at it from the front view and from the top view, I get a bit confused.
When you're looking at point AB from the front view, you can see that it is a line, right?
Mm-hmm.
So that line looks perpendicular to the XY.
Mm-hmm.
Ne? But to be sure, you have to look at the top view. And then if there is a point in the top view, then it means that line is the true length in the opposite view.
So in the top view, is it like a dot?
Because in AGD you want to have like a dot in the
Oh.
orthographic projection. So where the line starts, you see where in the top view,
Mm-hmm.
where that line starts, there is A prime, B prime. So those letters represents that there is a point there. Because if it was in a point, A was going to be alone and then B was going to be on the other side.
So
So
that's why the
yeah.
line is like breaking a bit there.
No. That line on your left, it's for the dimension. So they just dimensioning that the 15. Can you see 15 on your left? So
Mm-hmm.
that's a dimension. It's just that it's not part of the top view. That line is not part of the top view.
Okay.
It's just like the dimensioning in the front view, the 51 there. You can
Mm.
see that's just the dimension.
Okay, I get it. Thank you.
You're welcome. Any question or comment? If you want to add on what I just explained, maybe if you think that might help someone else understands better, you can also comment and explain your view on the topic if you want.
Can I please just confirm if I'm correct?
Yes.
So A prime and B prime, they're just showing that there's a dot there, like there's a point.
Yeah, if they are together like that, it
Mm.
means that's a point. There's a point there.
Mm-hmm.
Yes.
Okay. Okay.
Because you can see from B prime to C prime, that's a line.
Mm.
Yes.
Yeah.
So if it would have been a point also at
Mm.
C, they would have put C and D like point A and B there. So
Okay.
yeah.
So since BC is parallel to B prime and C prime, let's say for instance, um, BC, no man, BC, yes, BC was only parallel to the XY, and then BC wasn't parallel. So we're gonna take B prime and C prime as the true length.
Please repeat.
You see the distance from B to C in
Yes.
the front
Where
view.
in the front
Front
view.
view.
Yeah.
Yes. Let's say that one's still parallel to the XY.
Yes.
So, and then we look at B prime and C prime, and in this case, it wasn't parallel to the XY. We were going to take B prime and C prime as the true length
Yes.
of C.
Yes. Yes.
Okay.
Because the rule says if the line is parallel to the origin on one view, then it means the line in the opposite view will always be the true length.
Okay.
Yes. Any further question? No questions. Okay. So moving to the oblique line. So the oblique line is that line CD on the previous line, which is not parallel to the XY from the front view and also not parallel to the XY from the top view. That's an oblique line. If you take a look in the pictorial drawing, the line segment AB, looking at that line, you can see that from the front view, that line is not parallel to the vertical plane. And also from the top view, that line cannot be parallel to the horizontal plane. So it means that is an oblique line. So the rule says about an oblique line, if a line is not parallel to the origin from any view, make one of the lines parallel to the origin to find the true length. Make one of the lines parallel to the origin to find the true length. So thus, I understand the statement using the cone method. So this statement or this rule applies to the cone method, because looking at the orthographic drawing there, the line from the front view is not parallel to the origin, and also from the top view is not parallel to the origin. So the rule says make one of the lines parallel to the origin. It doesn't say which in which view. It just says make one of the lines parallel to the origin. So let's say I take line AB in the top view, line AB. So I'll have a line parallel to the origin first. Line straight parallel to the origin. And then I'll use a compass plotted on point A in the top view and point B, and make that line to connect with the line, with the construction line from the AB, from point A that is parallel to the origin. So in that way, I'm making line AB parallel to the origin. Then after making line AB parallel to the origin, the point will be, because I would have the line going from left to right, and then which will connect with point B with the compass there. So the point will be somewhere there. So from there, because you know that's point B, this will be your new point B. So you're taking that point B up, where it connects with, you'll also have a line from point B to the right, from point B in the front view to the right, which will connect with the line from the top view. So that will be your new point B also in the front view. So you'll take that point and make a line to point A there in the front view. So that will be your true length. That will be your true length. Any questions, guys? Any questions? No questions, no comments. Okay, we'll move to the next slide. So this is what I just explained in the previous slide. This is the generator of the cone method. This is how the cone method works. So first thing, you'll be having two lines that are not parallel to the origin from either of the views. So in the first drawing there, you can see you have point AB in the top view, and you also have point AB in the front view. That's all you'll be having. So if they give you initially, you'll be having line AB and line AB. There won't be that line there. That line, you will have to construct that line, and also that arc from B. From the questions, this arc won't be there, and this line that is parallel to the origin will not be there. So you'll only have A prime, B prime, and AB in the front view and AB in the top view only. So what you are going to do is what I've explained in the previous slide. You'll have to construct a line from point A across to the right, parallel to the origin. So from point A, we have to construct a line parallel to the origin, to your right. Then use a compass, point your compass at A, and at B, construct an arc where it meets with that line that you just constructed. That is your new point B. So it means you just made this line AB, parallel to the origin. So if that line you just made parallel to the origin, it means the line in the opposite view will always be the true length. But because you have the new B there, you can't use this B and that A to be your true length, because this line is the new line. So you also have to create a new line on the top view. So it means you'll have to create a new B. How do you do that? You drop this point down. The new B that you just created there, you'll drop the point down, like in the second explanation there. So step 2 says drop the point perpendicular to the XY ground line, move B prime out parallel to the XY ground line. So from B prime, you'll have to construct a line to your right that will connect with the line from the front view, that will connect with your new B from the front view there. You will have your new B there. That point will be your new B. Then you construct that line down where it meets with B prime. That's your new point B. And then it means you'll have to connect point B with point A. So it means that will be your true length.
What happened? Did people just leave the group, leave the meeting, or is it network problems? Or is it my side?